starting Chapter 2. Stuff in Chapter 2, we want to do some quick review of graphing, because you do need to be able to graph. And the things you've graphed previously were probably only straight lines. Now we're going to be looking at higher order functions, and you need to be able to graph those too. We're going to look later at some things to help recognize graphs and ways to take basic graphs and transform them to give you a different graph. But for now, we're going to look just at the basic idea of graphing these. And remember that graphs are images that indicate a group of ordered pairs, which are solutions to an equation or represent a function. So we're plotting ordered pairs, x and y. X is the first value, y is the second value. And you need to ensure you always write them that way. X is always the first value, y is always the second. And remember, x is horizontal, y is vertical. I see some students who get those reversed, and therefore their graph is wrong. So the ordered pair 2 and minus 5 is different from minus 5 and 2. You have to make sure you get them right. 4 and 3, another example of an ordered pair. The x value is the distance right or left from the origin. The y value is the distance up or down from the origin. And if you're going to do the graphing, if you're using a program like Excel, it will take care of making things uniform for you. If you're doing it manually, though, you have to take pains to ensure you draw your sketch of your graph as accurately as you can, given the tools you have. And it's not absolutely necessary to use a ruler and a straight edge to do it. You can do a decent job freehand if you take your time. Draw your axes and then mark off numbers, but mark them as uniformly spaced as you can. If you're not uniformly spacing your numbers on your axes, the graph is meaningless. Because it does not really, it's not something somebody can read. You must be careful about marking them so that they're uniform. So here is the normal rectangular graph that we're going to be working with. This is not the only possible type of graphing that you can do. There are circular grids that use a rotational coordinate system. There are spherical grids. Longitude and latitude on the Earth's surface are an example of a spherical grid. Those have different properties from this rectangular grid. This is the simplest, the easiest to work with. That's the only one we're going to work with in here. If you move on to higher level math and science, you will begin to encounter those other grids. There are actually several other types of grids. It's not always going to be rectangular, but they have special uses, and you won't use them unless you get into those uses, those special applications. So here's a rectangular graph. Origin is where the axes cross. Y-axis here, x-axis here. The point they cross is the origin. Numbers to the right of the origin are positive, to the left are negative. In other words, just the number line. Take the number line and rotate it up, and you get the y-axis. Numbers above are positive, numbers below are negative. Every point on that grid is uniquely identified by an ordered pair. There's no ambiguity. So for instance, a point like this, one of the things you need to be able to do is read that. What are the coordinates of that point? and that one, and that one. Right. So you're getting the order correct. That's good. Okay. If you have an equation in two variables, then you can graph that solution, and every point on that line is a solution to that equation. Because it's two variables, you have to have a pair that match to make the equation true, and therefore that's what you can represent with the line. For example, y equals x minus 1. If you graph it, you're going to get a straight line like this. Straight line, you can always tell it's a straight line because your x and y are both to the first power. Anytime both of them are the first power, it's a straight line. Linear equation. Straight line, you should have looked at several different ways to be able to graph that. One is just to create an XY table. Pick a value of x, calculate a value of y from the equation, plot the point. Pick two more values, plot them, draw the line. Another way to do it is picking your points, pick the x and y intercept. Remember what the x and y intercept are? What's the x-intercept? Where it crosses the x-axis. So in this case, that's the x-intercept. The y-intercept, same thing on the y-axis, where it crosses the y. Those are easy points to get because if you pick the x-intercept, then y is 0 at that point. So I could put 0 here and calculate what x is pretty simply. If I want the y-intercept, x is 0 there. And so I could put x equals 0 and get the y value very easily. Those are 2 points that are easy to get. You draw those 2 points, it gives you a straight line. You should plot a third point to make sure you didn't make mistakes. When it's a straight line, always plot 3 points. The likelihood of making a mistake that cancels another mistake is extremely small. So 3 points is going to ensure you get the right line. A third way you can do this is find a point and then use the slope of the line. What's the slope of this line? Nobody knows? Remember that equation? A couple of ways, and I think I heard you do it just by looking at the graph. That's one way to get it. 1 over 1. I was hoping you're doing the vertical first because that's what the slope is, yeah. That's one way to get it if you already have the line. Look at the graph and pick 2 points on the graph. Measure how much you change in the y direction divided by how much you change in the x direction. Y over x. Delta y over delta x. That's the slope of the line. If you don't have the line, if what you have is the equation, rearrange it until it's in that form, then whatever number that is the slope of the line. Here's our equation. It's in y equals mx plus b form. The number multiplying x is plus 1, so the slope is plus 1. An equation like that, you should be able to look at that equation and tell me what the slope is and what the y-intercept is. What's the y-intercept? It's the -1. It's the number, as long as it's in y equals mx plus b form, the constant there is the y-intercept. The number multiplying x is the slope. The constant is the y-intercept. So you can graph this line given the equation. Every point that is on this line, the ones that have dots in them and every other thing in between, every one of those values, those pairs, is a solution to this equation. a graph can be used to get specific values. It's more useful for quick, rough estimates and for looking at trends than for getting precise, accurate estimates. If you want a precise answer, plug into the equation. If you want a general idea or a quick answer like, what's the value of this equation? What's the value of x if y equals minus 2? Well, I can look on here, minus 3. Or, I'm sorry, y equals minus 2. X equals minus 1, if that's the case. And so you can get that. Or what if x equals 1.5? Okay, that's 1.5 is about here, which means that y is about a half. You can read off, but it's not precise. It's approximate. And graphs have that shortcoming, is they are always inaccurate. You cannot be 100% accurate with them. Only with the equation can you be 100% accurate. But if I want to say, how is this formula behaving, a graph can give me that idea. How quickly is it rising? If you're doing a nonlinear, where is it changing the slope and so forth? So with a straight line, you have 3 different ways you can graph it. But as you get into the higher degree equations, that really falls back to 1. Unless you're using, you can do that with a graphing calculator. You can do it with something like Excel. But if you're doing it manually, the only way you're going to be able to do it is to use an XY table. The reason that is you can't plot 3 points and then draw a line from it. An example would be a parabola. You all know what a parabola looks like. It's a U shape. 3 points on a parabola are not enough. And I say that because let's suppose I had this parabola. What if the 3 points I happen to pick were here, here, and here? What could I tell about that? That you don't really know the shape. If I just happened to pick those 3 points to plot, and I plotted them, what I would have would be something like that. There's absolutely no way I can tell what shape this is beyond right there. And so with a parabola, you're going to need more than 3, and you're going to need to have them spaced apart in a way that lets you determine the shape. So I'm going to get into a little bit of that. But you're still going to have to plot those. So when you're doing plots, we're going to be doing mostly functions. And functions will always cross the y-axis, but they will not necessarily cross the x-axis. If they cross the axes, those are very easy points to find because you can set the other variable equal to 0. Crossing the y-axis, you set x equals 0. Crossing the x-axis, you set y equal to 0. Those are usually good points to select when you're trying to find points on the graph because they're easy. And this one, as we said, the x-intercept is going to be where y equals 0. When I put y equals 0 here, I get x equals 1. So that's the y-intercept. I'm sorry, the x-intercept. The y-intercept is where x equals 0. If I put x equals 0 there, I get y equals minus 1. That's the y-intercept. 2 very easy points to get. Any other points, you have to plug numbers in. 2 points on a straight line are enough, but do a third to see if you made any arithmetic errors getting those. Nonlinear equations, you must have more. There's just no way you can do it with two. Most of the things you really can't do a decent job with three even. My rule of thumb is on a parabola, a minimum of 5. And really, on that parabola, those 5 points need to be spaced on both legs. Because you need to see not only where is the extreme point, that vertex, and how quickly does it go up, how quickly does it open out. You're going to have to do these points. So the best way to go about it is to organize it. And the best way to organize is probably the XY table. You create a table, 2 columns, X and Y. And you can either pick an X value and solve for Y, or you can pick a Y value and solve for X. It doesn't matter. Either one works. And sometimes, for instance, with the x-intercept and the y-intercept, it's easier to plug in a y value and calculate an x than it is to plug in an x and calculate a y. So it really doesn't matter when you're creating an XY table which value you pick. It's just you pick in one column and solve for the other column. So you get set up an XY table for this simple equation I keep going back to. Since it's arranged this way, you're probably going to wind up picking the x value and calculating the y, because the y, that's one of the easier things to do. So pick your values, calculate your numbers. I would probably wind up picking all the x and calculating all the y. When it's not linear, probably a good place to go is plot the y-intercept. In other words, set x equals 0, because it's easy. Solve for y. Plot the x-intercept. Set y equal to 0 and solve for x, because it's easy. Now, you may not be able to get a solution in some cases. Maybe that doesn't cross the x-axis. Maybe it doesn't cross the y-axis. But if possible, plot those, because they're easy. Then pick as many points as necessary to get an idea of what the shape of the curve is. My suggestion, plot 3 points. Whatever 3 points you want to plot, pick 3. Space them apart a little bit. Don't put them very close together, because if you put them too close together, you run the risk of what we saw a minute ago with the red line, the red dots, is it doesn't tell you anything. So pick them with some spacing and plot those 3 points. Calculate the values, what the pairs are, and put those 3 points on your graph. Look at what that shows you, and from that then decide where to pick additional values by looking at the graph. And maybe you pick 2 more values and plot those and see what that shows. And keep adding points until you're comfortable that you know what the graph looks like. For instance, here's a graph of y equal, or here's the equation y equals square root of 3x minus 2. If we want to graph that, I think the easiest way to go is to set your xy table, pick an x, and solve a y. It's set up for y equals, so if you plug x in and do the calculations, you get y. However, I have a problem. I can't put x in to be 0, can I? Because that gives me an imaginary number, which I can't graph. You can't graph imaginary numbers. So I'm limited on what I can do with my x's. I have to have x positive enough that this radicand is at least 0 or positive. And so I can try 0. 0 is going to give me a negative radicand. That's not going to work. So I'd try 1. Well, 1 works, because that gives me 3 minus 2, which gives me 1. That'll give me a graph. With something like this, where you have parts of the grid that you cannot get a value for, I can't have x be negative, right? Because that won't work. So where is it that I can begin? With this type of equation, you could set 3x minus 2 equal to 0. Set this radicand. And solve for x. At that value of x, if I put this in to this equation, I'll get the square root of 0, which is 0. That I can plot. Anything smaller than plus 2/3 will give me a negative number in here. Anything greater than positive 2/3 will give me an answer. So, if possible, and you should be able to, find that starting point. That's a very important point for a graph like this. Where does that line actually begin? It's not going to infinity, so where does it begin? And you have to look at the form of the equation. There are restrictions on this. You don't take the square roots of negative numbers. You don't divide by 0, things like that. Those general rules. Well, here, doing this lets us decide where that begins. Then I can pick any numbers I want greater than this. So I need to pick a couple. Pick this one. I'd probably pick 1 and 2 and see what it looks like. Draw that out. Based on what that looks like, decide how many more numbers I need to see it. So if I try 0, it gives me an imaginary. So try something larger. 1, that's okay. Then that's when I decided to find what number will give me a starting point. The smallest square root I have is 0. So whatever will give me 0 there is the smallest number I can allow x to be, and that's what this came from. And then just keep plugging numbers in. Notice minus 1 is also going to be imaginary. So from this, I have established that I can't use negative numbers. If you do this one, and this one, and then you can't do this one. Do this one, and this one, and graph it, then decide whether you need to do more. The first 3, this one, and this one, would be these 3 points. The 2/3, the 1, and the 2. I'd probably jump out here somewhere for my next one. Rather than doing this one or this one, I'd jump somewhere out here. If I go all the way to 6, then I actually get back on an integer. And, you can play with things like that by what number will give me a perfect square. But these 3 points by themselves are not really quite enough to tell the shape. You need another 1 at least, if not 2. But by looking at that and knowing you can't go any further this way, then how much further out here do you move to get your next point? And you can decide that, but move somewhere out here. If you want to do the next one, in order, that's fine. Until you get enough. If you do 3, that'll give you that. That's maybe enough. Okay, perhaps by then that's enough. But if I see this, I'm probably going to jump out a little further because it looks like it's changing nice and smoothly, but I want to ensure I get to see how quickly it opens, so move out a ways and see how quickly it moves up. Okay, here's another one. Y equals minus x squared plus 1. If we want to graph that, create an XY table. This one, I really can plug just about anything I want to in for x, can't I? No matter what I plug in there, x squared is going to be a positive number, and then the minus will make it negative. And whether I add 1 to a positive number or add 1 to a negative number is not going to make anything go haywire. So I can really pick any x value I want. 0 is easy, will give me 1. Pick 1, that'll give me 0, and so forth. Probably pick those 3, 0, 1, and 2, and plot them. Based on what that looks like, decide how many more of these I need. That way you don't wind up, calculating 10 or 15 numbers and then start plotting and say, wow, I didn't need all these. Do 3 and then continue from there. So this one, if I do 0, 1, and 2, I get these 3 points. And 2. Those are the 3 points I get. And that's, doing a reasonably good job of doing it, except what's happening over in the negative side. And actually, you should be able to look at this and say that's a parabola, because it has y to the first power and x to the second power. We're going to be doing some more of that, looking at basic function shapes. And the parabola is one of those basic shapes. But you see that, then the next thing you want to do is, okay, I need some points over here. So pick some negative numbers. Don't keep picking positives. And so something like that. If I had picked this one, and this one, then I need 1 on each side. But use the graph as a guideline. Calculate a point, put it in. Calculate a point, put it in. And that way you can stop when you have enough. Let me go back to here for a moment. The basic plotting is something you need to be able to do. And be able to plot nonlinear equations, not just straight lines. As we move into this more, you're going to need to be able to do some things with graphs where you're not necessarily plotting them, but you're going to need to match a graph in an equation. So you need to know what the characteristics are. And sometimes the way you have to do that is you have to actually calculate a few points that would be on the graph in order to see, is this the graph I want or is this the graph I want? Okay.